Welcome back to the GCSE Maths Pro YouTube channel. Today's video is the first part of Pythagoras and Trigonometry, where we will be just looking at Pythagoras' theorem. As you can see, these are all the other parts. The first two videos are for foundation tier and anything beyond that, so 3D trig and higher tier trigonometry is obviously therefore for higher tier students. So take a screenshot of this page. This is your summary of the formula. If you are doing your GCSE maths in the year 2024, I'm pretty sure that you will get this formula on your formula sheet as part of the extended COVID formula sheets. However, it's not really too complicated to memorize anyway. And if you are doing a GCSE next year or onwards, you will need to memorize all of this formula. So what is Pythagoras' theorem even for? Well, it actually sounds a lot worse than it is. So as you can see here, Pythagoras' theorem is used specifically in right-angled triangles, okay, so they have to be a right-angled triangle, when you're given two sides and then you have to find a third side. So it could be any combination of any of these two sides that you're told, and then you have to find whatever the third missing side is. Okay, so nothing to do with angles, just two sides given and one that you're finding out. Once you've figured out that you need to use Pythagoras' theorem, you then have to make sure you label the triangle correctly. So label all three sides A, B and C. A and B don't really matter between them. The most important one to know and the most common mistake that students make is which side is C. Now, as you can see here, C has to be the hypotenuse. That means the diagonal side. So however you remember which one is the hypotenuse, whether you think of it as the diagonal side, whether you think of it as the one opposite the right angle, that's fine. Whether you think of it as the longest side, because technically the hypotenuse is always the longest, it doesn't matter. Make sure that you label C as the hypotenuse, okay, as the diagonal side. It's not necessarily the one that's missing. Okay, a lot of students just think, oh, whichever one's missing, that one is C. No, it could be missing sometimes, because we might want to find out this diagonal side, but it's not always the one that's missing. Okay, you might know what C is. So it has to be the diagonal side. I'm really emphasizing that because that is basically the main mistake that's made with this topic. I will have the formula on each of the questions, but make sure you make a note of it or screenshot this for your revision. So let's just go straight into it. It's pretty much as simple as that. They might not tell you you need to use Pythagoras' theorem. So for example here, the question just says, work out the length of x. Okay, you might have to kind of know, oh, okay, I need to use Pythagoras in this circumstance. But once you've figured out you need to use Pythagoras, it's just a question of labelling the sides correctly and then substituting the numbers in. So, as I said, I always tend to label C first because that's the most important one to get correct. In this case, C, obviously, well, in every case, C is the hypotenuse, but in this case, it is the one that we don't know, isn't it? C is, in this case, X. A and B have to be the vertical and horizontal sides, or the sides that are joined together by the right angle. As I said before, it doesn't really matter if you put B here and A down here. Like, that doesn't actually matter as long as A and B are these vertical, horizontal sides, the ones that are perpendicular. C has to be the hypotenuse. Okay, so now that I've mentioned that a million times, once you've done that, I'm literally just copying the same formula, but substituting in the values. So let me just write it down here so you can see it in the middle. We've got A squared plus B squared equals C squared. Don't forget that they are all squared, because a lot of the time people think it's just A plus B equals C. They are individually squared. But now I know, okay, well A, in this case, is 4, isn't it? So I just put that as 4 squared. B is 3, so 3 squared. And C is technically X, isn't it? So you can put C or you can put X, doesn't really matter. There we go. Then, as you can see, it's kind of just algebra at this point. In this case, I'm going to add together 4 squared plus 3 squared. Okay, so 4 squared plus 3 squared. Obviously that gives us 25. So I'm going to keep writing out fully, as in as a full equation. So I'm not just going to write equals 25, I'm going to put equals x squared. The reason why I write that is because I'm looking for x, and I need to remember at the end, the answer is not 25, okay? I need to square root. So my final step is to do the square root of both sides of my equation, which is obviously just 5. Okay, so in this case, the answer is x is 5, so 5, obviously, centimetres. There we go. So you will have to square root at the end, okay? Just don't forget that. That's why I like to write out the full equation with the x squareds on this side as well. But that is literally it. The answer is 5. Okay, so label the sides correctly, substitute into the equation, and then solve it. Okay, let's look at another one now. So work out the length of x. In this case, they've said to 3 significant figures. You can see now x is a different side. So our first step is always to label the sides. C is the most important one, so C is the hypotenuse, the diagonal one. In this case, C is 8. And then as I said, A and B doesn't really matter which one you put it as which, so I'm going to put A here and B here. Step 2, substitute into my formula. So I know it's going to have to be a squared plus b squared equals c squared. Now, in this case, a is x. You see how the x is in a different place now, it's x squared, plus b squared, so 5 squared, and equals c squared, which is 8 squared. Okay, so it's in a different format now. I've got the x on the left-hand side. So to solve it, I'm going to have to do a bit of rearranging as well, aren't I? So I might work out the square numbers first. So I've got x squared plus 25 equals 64. Now, if I want to solve this equation, just think literally about algebra now. I'm going to have to get x on its own. So I need to move 25 across, and by subtracting, then it will cancel out, won't it, on that side. So x squared is equal to 64 minus 25, which is 39. And then again, don't forget at the end, we need to square root it. So x is equal to the square root of 39, which it will give it to you like that, but they've asked for 3 significant figures. So I'm going to press this SD button here to convert it into a decimal. 6.24499, so on. 3 significant figures, so we've got 6 is one of them, 2 and 4. Check the next one is 4, so I don't need to round up, so it's 6.24 to 3 significant figures. Okay, so the steps are the same, but depending on which side is missing, you might need to do a bit of rearranging as well. Okay, but that bit is just relating to algebra. Okay, if you're getting the hang of it, have a go yourselves now. Obviously, these will be calculator questions, so make sure to use your calculator, and let's give it a go. So work out the length of x to 1 decimal place. Again, step 1, label the sides. C is my most important side, which is the diagonal. Okay, so the hypotenuse. So that is C. A and B, it doesn't matter. I'm going to substitute into my formula, obviously the formula being a squared plus b squared is equal to c squared. A in this case is 6.5, so 6.5 squared plus, now this one we don't have b, so you can either leave it as b or you can put it as x squared, whichever you like, equals c squared, which is going to be 14.3 squared. Again, I'm going to have to rearrange this, aren't I? So I might work out these squared numbers first. Okay, so 6.5 squared is 42.25. You don't have to write this down, but you might prefer it instead of just doing the calculation straight away. 14.3 squared is 204.49. Okay, and as you can see, again, we want to get x on its own, so I'm going to have to move this 42.25, which we're going to have to subtract again. So subtract from both sides, because that's how equations work. 42.25 gives us 162.24. So we've got x squared left on this side, and 162.24 on the other side. And finally, don't forget again to square root. Now they've asked it to 1 decimal place. Because it's our final answer, now I can round it. 12.7 would be the final answer. That is literally it. That is the basis of Pythagoras' theorem. Okay, so now we're going to look at a few slightly harder questions. The Pythagoras' theorem itself is still the same, but it's just in the context of slightly more complex questions. So work out the length of x to 1 decimal place. Now you can see the main difference here is we now have 2 triangles. Okay, so we've got x on the left-hand side. However, if you think about it, Pythagoras is for when we have 2 sides that we want to find out the third one. In this case, for the left-hand triangle, we've only got 1 side. So we don't currently have enough information to even work that out. So we're going to have to therefore use the right-hand triangle, which does have 2 sides, and the missing side happens to be the one which it shares with the left-hand triangle. So we're going to use our right-hand triangle to work out this vertical side, and then we can use Pythagoras again to work out x. So in this case, it's still Pythagoras, we're just basically doing it twice. Let's put 1. We're going to have to label this right-hand triangle, so C is always the hypotenuse, and then A and B doesn't really matter. There we go. Fill out the formula, so a squared we don't have, plus b squared, which is 9.1 squared, equals c squared, so 17.9 squared. Okay, let's work those out. Okay, so we've got a squared plus 82.81 equals 17.9 squared, which is 320.41. Okay, now this one we do have to rearrange, don't we? Because we want to get a, in this case, as the subject. So I'm going to have to subtract by 82.81 on both sides. So I'm left with a squared as 237.6. Now don't forget that you always have to square root. So square root answer gives us 15.414, so on. Now, because this isn't the last part of the question, I'm going to write down maybe 2 or 3 decimal places, but I'm going to use, if you see at the bottom of my calculator, I have this ANS button. I'm going to use the answer button when I then obviously use the 15.4 in the next part of my question. So you don't have to write down all of the decimals, but do try and keep your answer in your calculator. I'm going to write down just like 15.414 ... centimeters. So that is this side here, isn't it? Okay, now we've done that, we can come back to our left-hand triangle, because now we do have 2 sides that we know and 1 that's missing. So I'm basically just going to have to go through the process of Pythagoras again. So with a different colour, I'm going to label the triangle. So C is the one that is the diagonal, the hypotenuse, and then A and B doesn't really matter. So let's keep A as the one that we already had as A, and then we'll put B as the base here. I'm going to write down 15.414 squared. However, in your calculator, I want you to use the answer button squared, okay? Plus B squared, which is 21.4 squared, equals, in this case, C squared is the one that we don't know. So I just have to put that in my calculator. So I'm going to take my answer and square it, and then put plus 21.4 squared equals, okay, 695.56. And that equals C squared, but again, remember we need to square root at the end. So square root answer 26.3. Now, because this is the final answer, isn't it? The C was the X. We were asked to work out what X was. Now I'm going to finally round it to what they've told me. So they said to round it to 1 decimal place, which gives me 26.4. Okay, so my answer is 26.4 centimeters to 1 decimal place. So it's not really harder, it's still the same thing, isn't it? But we just had to do the same process twice to 2 different triangles, that's all. Okay, the second type that they could give you, where it's a little bit more complicated to figure out, is this one. So the triangle ABC is an isosceles triangle. Work out the height of triangle ABC. So obviously this dotted line here, that's the height that we're looking for. Now, as we said, Pythagoras' theorem only works for right-angled triangles. However, you can split shapes up into right-angled triangles. So for example, if this is an isosceles triangle, obviously we know this side will also be the same, right? Those are the 2 same sides. If I were to draw this dotted line straight down the middle, technically that would be 90 degrees on each side, wouldn't it? So I've split ABC, the triangle, into 2 right-angled triangles. Okay, so you could draw a line there if it's not already drawn for you. I'm just going to use the left-hand side. Okay, right, so we want to find the height, which is now one of the sides of my right-angled triangle. I've got 13, and then if you look at the base, I now only want from B to the midpoint. If they've told us that BC completely is 10 centimeters, I can obviously then assume that B to the midpoint is going to be 5, isn't it? Because of the fact that it's an isosceles triangle, okay, not because it looks like it's halfway, but because we know mathematically it is halfway, isn't it? So I'm actually going to be using 5 centimeters for the base. Okay, so just be careful. Make sure you remember if you've got an isosceles triangle to half that base value. Now I'm just back to the beginning. I'm going to use my formula for Pythagoras. So I need to label the triangle. C is obviously the hypotenuse, which is 13. And then A and B, it doesn't matter, so I'm going to call the height A and the base B. And then just sub it into my formula. So A squared, which is the height, so let's do H squared, plus B squared, which is 5 squared, equals 13 squared. Okay, so height squared plus 25 is equal to 169. And then obviously, again, I just need to rearrange it, don't I? So I need to take away 25 from both sides to leave me with the height squared. And that gives me 144. And then I just need to square root. Luckily, this one is a square number, so I get 12 centimeters. Okay, so the height is 12. The other thing to consider when you're doing Pythagoras is double check your answer. I don't mean necessarily work through your workings again. Obviously, if you've got time, you can do that. What I mean is double check, does it make sense? Because with right-angled triangles, the hypotenuse is always the longest side. So I knew the height is quite tall, but it has to be something less than 13. Because 13 is the hypotenuse and that is the longest side. So the fact that my answer is 12, I'm double checking with myself. I'm like, does that make sense? Is that realistic? Well, yeah, it is. Because if I go, oh, my answer is 144, does that make sense? Is that realistic? And then I go, oh, well, I know it needs to be smaller than 13. Then I might pick myself up on an error. As I said, a lot of people forget to square root at the end. Obviously don't forget to do that, because 144, if you look at all these numbers, it doesn't make sense, does it? If you've got 13 centimetres, we've got 10 centimetres down here, where does 144 come from? So always go through, especially with Pythagoras, with trigonometry, and go, does my answer kind of like make some sense, basically? In this case, yeah, 12 seems reasonable, doesn't it? So that's fine. Okay, this is a similar question, purely in the sense that you're probably looking at it going, that's a trapezium, that's not a right angle triangle, what are you going on about? Again, drawing lines into these questions. If you've got shape questions, you can draw any lines wherever you want. So it says work out the perimeter of the trapezium. Okay, perimeter is obviously when you take all the sides, add them together. Well, first of all, it's fine, we've got 3 sides, but we're clearly missing this diagonal side here. So what that leads me to do is to draw a straight line across, okay, horizontally, because then I can create a right angle triangle, like so. So I can add that line in myself, because I know that's therefore a right angle triangle. Okay, now you're looking at it going, yeah, but I've got none of the sides. How am I going to use Pythagoras if I've got no sides? Well, first of all, if I draw a straight line straight across here, I'm creating this kind of rectangle, aren't I? Therefore, the base of the triangle must also be 4 centimetres, mustn't it? It's basically the same as this one down here. Okay, so I've got one side. Now, obviously, if I want to find the diagonal side, the hypotenuse, I'm going to need this one here. Now, don't look at it and go, oh, that might, because sometimes it looks like it's half of this side. Don't look at it and assume what it is, okay? We have to mathematically either work it out or have a reason that, mathematically makes sense. Because things are never drawn to scale, so never assume something of a measurement by just looking at your page. In this case, I know that this height is 7 on here, and then this height is 9. So the height of my triangle must be the difference between the 7 and the 9, okay? So that's how I'm going to work it out. So 9 minus 7 is going to give me 2. Again, none of this is drawn to scale, right? None of this is accurate, so don't make any assumptions. Don't go, oh, that looks like it's a third. Maybe I'll make it as 3. No, there should be a way to work it out mathematically. We shouldn't ever really be guessing. Okay, so we've done 9 minus 7, these 2 vertical sides subtracted, okay, to get the 2. Now, I'm going to go back to using Pythagoras. So, label on my sides. So C is obviously the diagonal one, the hypotenuse. In this case, it is the missing side. And then A and B you can label as you wish. And we just fill out the formula. So we've got 2 squared plus 4 squared equals C squared. This time we don't need to rearrange anything, do we? We can just add these together. So 4 plus 16 is 20, which again, write it out fully so you remember that that is C squared, okay? Then I need to square root it. So C equals the square root of 20. Now, I'm going to round it to, let's go with 1 decimal place. It hasn't told us. If it doesn't tell you, you can round it to whatever you feel is appropriate. Normally at least 1 decimal place, if not more. I'm going to just go to 1 decimal place. That would be 4.5. 4.5. Okay, so now we know that this side here is 4.5. Don't forget, though, that our actual question was asking for the perimeter, wasn't it? So don't forget the last bit. Okay, so that was like step 1. Then there was step 2, which is the perimeter. Obviously, perimeters just add them all together. So we've got 4.5 plus 7 plus 4 plus 9. There we go, 24.5 is our answer. And that is to 1 decimal place. Okay, so you can always draw lines in if you need to create right angle triangles within your bigger shape. That's fine. Okay, our last question is more of a worded question, okay, a worded scenario. So, a plane is flying from London to Mexico. It flies 5,500 kilometers west, then 3,300 kilometers south. How far is it directly from London to Mexico? Rounded to the nearest 100 kilometers. In this case, we're going to want to just draw the whole thing ourselves, aren't we? So we're drawing west, so that's literally going to be a line horizontally. Okay, that one is the 5,500, isn't it? And then it turns and it goes south. Okay, so that's south. Now, because we're working west and south, we know that that should be right angle. And then they've asked us how far is it directly. So for example, obviously we're starting here, so that was London. And we end up in Mexico here. So directly is creating that triangle. Okay, so you might have to sketch it yourself sometimes if it's a worded one, but feel free to do that so you can visualize it. We want to work out this diagonal here, don't we, the hypotenuse. So, do you see how it's another scenario to use Pythagoras' theorem? We've got a right angle triangle, 2 sides, and missing the third one. So I'm going to label it. Obviously, C is the diagonal, the hypotenuse, and A and B can be whichever of those two. So, A squared, we've got 3,300 squared plus 5,500 squared equals, in this case, C squared, because we don't have that one. Now, this one I can just put straight into the calculator. Okay, that adds up to 41,140,000. And again, remember that is c squared, so I need to square root. Square root answer, here we are. Now it has said rounded to the nearest 100 kilometers, so we've got 6,414. To the nearest 100 kilometers would be 6,400 kilometers. And there's your answer. Okay, that's literally it. So hopefully you found that quite repetitive in the fact that we just use the formula the same way, label the sides, plug it into the formula, solve the equation. So that covers a variety of questions on Pythagoras' theorem. Hopefully you found that helpful. Next video in the series for both foundation and higher tier is basic trigonometry, where we go through SOHCAHTOA, which is fairly similar. And then beyond that, we've got everything higher tier. Okay, so thanks for watching this video. Make sure to like and subscribe and comment down below any questions you might have.